All right, we're going to go and cover Appendix F out of the textbook, which covers sigma notation, some known sums, and then some infinite sums. And this is really going to help when we cover the definition of integration, all right? And so, when we learned how to take the derivative, we learned the definition and then we learned the shortcuts. All right, the same thing is going to happen when we introduce integration. We are going to use the definition first, and then we'll learn a few shortcuts this semester, and then next semester you'll learn even more integration techniques. So even though we did some of this in 5.1, right, it never hurts to review. So if we have a sigma summation from I equals some number m to some number n, right, and here's a sub I, these are all our terms, right, so the summation is going to start when I equals m, so we're looking at a sub m, and then we're going to increase our index by 1, so our next term is going to be a sub n plus 1. And then, if we wanted to do a next one, we could do m plus 2. And we're going to keep increasing that index by 1 until we get to the top number. So I is what we call the index of summation. M and n have to be integers. And m has to be less than or equal to n. All right, the bottom number has to be less than or equal to the top number. So we're just going to do some sample summations here. So let's sum from 1 to 4 I squared. All right. So we're going to start off with an I value of 1. So the first term is going to be 1 squared. The second term, we're going to increase I to 2, is 2 squared. The next term would be 3 squared. The next term would be 4 squared. And then we would stop at 4, right? So we're looking at 1 plus 4 plus 9 plus 16. 25 and 5 is 30, right? So this summation equals 30. Let's do another one. Summation from 1 to 3, I minus 1 over I squared plus 3. So the first time through, we're just going to plug 1 in. The second time through, we're going to plug 2 in. And then the last time through, we're going to plug 3 in. All right, so the first fraction, 1 minus 1 is 0. 1 squared plus 3 is 4. The second fraction, 1 on top, 4 plus 3 is 7. And the third fraction, a 2 up top, 9 plus 3 is 12. All right, so if you add all those up, I'm cheating here, I'm just copying my answer. All right, you should get 13 over 42. So now let's do the sum from 1 to 4 of 2. Right? Notice that this is just a constant. There is nowhere to put I, right? But if I is 1, then the term is just 2. Okay, and then we're going to add that. Now we're increase the I to 2. And so if I is 2, the term is, again, just 2. Then change it to I equals 3. If I is 3, the term is just 2. And then increase it to 4. And if I is 4, the term, again, is just 2. So the summation from 1 to 4 of a constant is just adding that constant 4 times. And so we're going to get 8 for an answer. All right. So then let's look at the summation from I equals 1 to 4 of 2I. Oops, sorry. So if we kind of enumerate this, we're going to get 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4. So notice, if you will, we could add this up. Okay, we would get 2 plus 4 is 6, 6 plus 6 is 12, 12 plus 8 is 20. We would get 20, right? But I want to rewrite this. Since every term has a 2, we can write this as 2 times the sum of 1 plus 2 plus 3 plus 4, which is kind of what we did when we did those delta x, right? We factored the delta x and just left our function evaluations on the inside. And if we were to write this, 1 plus 2 plus 3 plus 4, that's a sum, right? It's a sigma sum. This is equal to 2 times the sigma sum from 1 to 4 of just I, right? So if it just has a constant times I, we could factor that constant out, which is very helpful, right? So keep that in mind. All right, so now I want to give you a summation, and then you write it in sigma notation, right? So write in sigma notation. All right, so we're looking at 2 cubed plus 3 cubed plus all the way to, let's just do 8 cubed, right? So what do you think? We're just cubing the base number, right? So we're going to do the summation. We're going to start at 2 and end at 8, right? So I equals 2 to 8 of I cubed. That would work, all right? So what if we had to start it at 0? Right? What if we had to start I at 0? So now we're going to start our I summation at 0. Right? Where do we end? Okay, and what is our argument now? Right? So when we plug it into our argument, we should get the first term to be 2, right? So we want to do I cubed, right? But when I plug 0 in here for the I want my first term to be 2. So what if I added 2 here? Okay, so now I get 0 plus 2 is 2 cubed. And then if I increase this, 1 plus 2 is 3, 3 cubed. Okay, and if I increase it again, I'll get 4 cubed. Now I want to stop at 8 cubed. So I want this, the smallest, the biggest this can be is 8. So the biggest I can be is 6, right? So we're going to have 6 terms there of that number cubed, right? 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7 cubed, and 8 cubed, right? So sometimes they're going to make you not take the easy way out here by changing your index, okay, where your index starts and ends. Sometimes they're going to force you to start it at 0, okay, and make you think about where does it need to end and what do the terms need to be. All right, so I think I'm going to end this video and start a next one, but I'd like to end this one with some laws of summation. All right, it's a theorem. And those laws are 3 of them. Okay. If we have a summation of a constant times a sub I. As a law, we can always take the constant out in front of the summation and do the constant times the summation, right? Like factoring out the 2 or factoring out the delta x. This will always be true. All right. The second law that we can do with summations is if we have a sub I plus b sub I. Okay, the sum of a sum is the sum of the sums. All right, we can split these up. Okay, we can do the sum of a sub I and then add to that the sum of b sub I. All right. Now, if we can do that with addition, all right, subtraction is going to work the same way. So we have I equals m to n. If I had a sub I minus b sub I can split these up to 2 different sums. Right? Now, there isn't a D and E here. Okay? It does not work for multiplication and division. So be aware. Right? So this does not apply to multiplication and division. All right. So that's just the basics of sigma summation. Have a great night.